right? Now, these were the forms of materials. The next thing is atom. And the basis of the atomic internal structure, you divide different materials into different classes. Viscosity determines the state of a system. An atom defines the band structure of a material. And it is very, very simple that when the atom has loose electrons, obviously when they are big atoms, for example metallic atoms, they have more loose electrons. We define metals as something which consists of cation floating in the sea of electrons. Floating in the sea of electron means that you have positive cations at different places, and there is a sea of electron. So this electron, I am picking this. Is it connected with this one, this one, this one, this one? Which one? It is connected with everyone. Some field, because of that nucleus, has a fraction of contribution to the attractive force towards it. But at the same time, the atom is not tightly bound. When the atom is not tightly bound, we are never saying it's a free electron, but we are saying almost free electron. Right? Free electron and almost free electron. Almost free means a little bit force is needed to push it or pull it, to release it from the atom. So, these electrons, for example, in comparison to these, you have silica. The electrons are tightly bound. Here, you can never say that the electrons are almost free. This bonding, this tightness of the bonding gives the band structure to the relevant element. So the elements which have almost free electrons in them, this means when voltage is applied, the electron movement will start and the current will flow in them. The material will be ductile. If there are more loosely bound electrons, in this case, if this is ionic bond, either the bond is there, when the bond is there, the solid is there. When the bond is not there, the specific structure is no more there. But in the case of metals, if this cation is here or there, if this electron is binding this with this or not with this, still there are many electrons to keep it intact. What does this mean? When you pull it, it will not break. But when you pull this, it will break. I force this to break. If it is brittle material, it will break. If it is metallic material, metallic means ductile material, which can undergo plastic deformation, elastic deformation without breaking, I call it metal. Right? So, the brittleness and the elasticity depends upon the structure of the material, and conduction is totally dependent upon the availability of electrons. If you have free electrons, which I told you, they are never free, almost free. Use the words carefully. Which can be easily displaced, which can be easily plucked out of the atom. Attraction. They are conductors. So, depending on the band structure of material, obviously associated with the relevant atoms, we divide materials into 4 classes: metals, semi-metals, semiconductor, and insulator. Where there is no conductivity, we call it insulator. When it is intermediate level conductivity, we call them the semiconductors. And the other 2 classes are conductors. Depends upon them. So here the decisive factor, the decision maker of the classification is the atomic structure. Viscosity, the strength at specific position, unflowability determines the state of a system, but the atomic structure on its own determines that whether a material is conductor, semiconductor, or insulator. So, based on the electrical properties, you divide material into these classes. But you must keep in mind that these divisions or distribution things into different groups are not something which you should 100% believe in them. These are for your ease, that you can easily classify things. For example, I bring to you this remote control and I tell you this is made of some brittle material. This brittle means you will not try to subject it to tensile pressure, because in tensile case it will break down. It will have compressional strength. These blocks, these bricks, if you try to bend them, they will break. But if you put a building upon them, they will stay in it. So they have excellent compressional strength, but very poor tensile strength. And this is just like the farmer, that when he looks into the cloud and tells you about what is going to happen. A material scientist must look into the material, understand it, and then use it accordingly. Why people die? Because they don't know what is going to happen if you use this thing. If you are driving a car and you don't know to drive. If you are eating a medicine and you don't know what its behavior will be. You are eating a food and you don't know what will be its consequences. You make friendship with someone and you don't know who he is, how will he behave. Is he a murderer or a very nice friend? So this is the knowing, the outcome of the knowing. So in the case of materials, you focus upon the property. Yes, aesthetic sense. Do they look beautiful or not? You have choices there. You can make things beautiful. But the basic thing is the property. And the basic property comes from physics and chemistry. That what will happen to that. So on the basis of atomic structure, you classify materials into these classes: insulators, semiconductors, conductors, superconductors, and go on. Don't draw hard lines, because things are changing with time. And what we are teaching you, these are the fundamental things. When you move forward, for example, I commonly tell my students that a material will form. A material will form a specific phase if it gives free energy. allows it. If the energy, this brush will bond with this remote if the Gibbs free energy is coming down with it. If it is increasing, then they will repel each other. Right? But there are many materials which don't want to come together because of the energy, but we still make them. So when we talk of such things, we are talking of naturally happening things. Artificially you do many things which are not allowed by the natural laws. Right? So the nature, we are talking of equilibrium phases. When you are talking of equilibrium phases, then that will not happen. But we are hard pressing material which don't combine together, but we heat them up together, and when they bond together, we cool them and suppress their wishes. They want to go away, but we have increased the kinetics are born in such a way that potential wants to repel it, but we had not allowed, we are not giving space to them. You want to go out of this room, but I have locked the door. We are doing the same thing. We combine a material in a specific set of parameters and then don't allow them to come back. Whenever they find an opportunity, they will come back. And that introduces metastability in phases. Some phases are stable, some are metastable. Metastable means that when they find an opportunity, they will go to the stable state, but after having that energy. Then a third thing which is important, we said viscosity, then we said the internal structure of an atom, which classified materials into property. And other important thing is how the atoms are placed in a material. How the atoms are placed in a material.